To cater for our environmental needs, governments and specifiers are increasingly moving towards the specification of permeable paving. Here we take a look at one such category, grassed pavers, for where you might be surprised to learn there's no industry standard to benchmark the performance characteristics of the available types. Instead, architects and engineers are often pointed towards a confusing array of manufacturers' performance claims. These often focus on compressive tests carried out on individual components to determine their resistance to crushing. The results may sound impressive, but this process bears little relationship to the type of load that the paver will face or how and why it will fail in an actual installation. With a complete range of grass pavers available, Grasscrete Limited has used its own 50-year history of installations to create its own empirical benchmarking for its available types. In particular, their Grasscrete system has a long history of success in demanding applications, including some real-life emergencies. Grasscrete is further backed by independent engineering design using traditional bending moment analysis and then by full-scale on-site testing. Here we take a look at one such test to determine the suitability of the cast in situ Grasscrete system for use in fire and emergency access tracks. To take the Grasscrete to the limits of what can be expected back in the 1980s, we went to the home of big fire trucks, the USA, and in particular to California, the home of Grasscrete's US licensee, Bowmanite. They established a full-scale test in partnership with the city of Fresno and its fire department. The truck used for the test was one of the largest models in the United States, with a weight of 33 tons and a 30-meter extension ladder. Here we see Bowmanite Corporation's chief engineer explaining the details of the test site and procedure to the Fresno fire chief. This plan shows how the Grasscrete slab was divided into a total of 12 different areas, so as to be able to assess the performance across a range of operational scenarios. The fire truck's outriggers were placed in the center of these sections, and the test was performed in various positions with differing degrees of groundwater to simulate operational conditions. And here we see the 33-ton Grumman ladder truck being driven into position for the testing. This dial indicator was positioned so as to measure the exact deflection of the Grasscrete slab. First, when the outriggers were extended, and second, when the ladder was extended to full length, loaded and lifted off the ground. The Grasscrete test generated a good deal of interest among the media, with the Bowmanite chief engineer being interviewed by a local television station. Here he's explaining that the entire test, including construction of the Grasscrete, was supervised and reported by a registered professional engineer and an independent testing laboratory. The first interesting part of the test was when the outriggers were extended and lifted the entire 33-ton truck off the ground. And up comes the truck. At this point, all the weight was concentrated on the 4 outriggers. Here you can see the front wheel off the ground, and the rear wheels as well. As we watch the 30-meter ladder being raised and extended to its full length, it would be helpful to review the principal design criteria for the design of emergency vehicle access roads. First, an emergency access road must provide safe access. Second, it must be capable of taking the operating loads of the vehicle. Third, it must provide even and stable support for the vehicle's stabilizing equipment. This is the most important aspect, which is about to be tested here. The road might be one that's only to be used in an emergency, but it's vital that when called upon, the emergency services can fully operate. Finally, the access road must blend aesthetically with the surrounding environment. Before the basket at the end of the extended ladder is filled, the fire chief and his assistant are making some last-minute adjustments. Since people are going to provide the weight in the basket, they're being weighed so that the testing lab will have the exact total weight in the basket. The full weight in the basket is 365 kilograms. Engineers may want to calculate the force that such a weight at the end of a 30-meter-long ladder will place on the outriggers. An important point here is that the soil both within the Grasscrete slab and underneath the slab was thoroughly saturated for this part of the test to simulate what could happen in a full-on emergency. You can imagine what would happen to an alternative unreinforced modular block system when such a weight was exerted over saturated soil. The actual deflection of the Grasscrete slab in the section with minimal size reinforcement and no prepared subbase was only 1.6 millimeters. The test has shown Grasscrete's ability to withstand the operating loads of the world's largest fire appliances, but its capabilities don't stop there. It's regularly specified for abnormal load routes, where with multiple axle configurations, vehicle loads of up to 275 tons have been accommodated. In one such example shown here, the surface has been loaded before grass growth, helping to prove the standalone capability of Grasscrete's fully reinforced structure. Further highway-based applications include this sky cradle bay to enable high-voltage cable replacement without closing the highway. This helps to show Grasscrete bearing load before grass growth and as a mature maintenance lay-by once grass is established. Living with Grasscrete is easy when you know the type of load it can handle.